a way of programming or a way of coding. It's a programming paradigm. It's not a library. It's not about any additional, library or framework that you can introduce in your project in order to make it work in an optimized manner. It has to do a lot with, the dev experience, the way you write programs, just like you introduce design patterns to your programs. It's like a design pattern that you can say. And it's there are two main important characteristics, two main pillars of functional programming. First is that the program is built by composing tiny reusable pure functions. We'll cover what pure functions are and how it differs from impure functions. And we emphasize on writing declarative code instead of imperative code, right? And it's functional programming is a way about rewiring your thinking process of looking at approaching of writing a program, a piece of code in a declarative process by composing functions together rather than composing statements together one after the other. Then we'll see how it's associated with the mathematics, the principles of mathematics, because maths can't be proven as false. So similarly, if we bring the goodness of maths, the truthness of maths into our programming world, our programs will actually be bug free. So we'll see how that'll work. And it again, as I mentioned, it's not about using any third-party library. So most people have this convention and have this thinking of only we can use functional programming only if we use Lambda or Lodash into our projects. So that will introduce an overhead. You have to bring that new library on the table. So you have to convince everyone of using this new library. But that said, while that is useful, but you can implement functional programming without the need of those third-party libraries. And we'll see why those third-party libraries are needed as we approach towards the end of the session. Cool. So the very first thing that we would want to discuss is what is imperative and declarative code. So if you look at this code snippet on your screen right now, what it does is it has an array of products, and you have to sort out the best products based on some criteria. So if I ask you to understand this piece of code, you'll have to read this whole code line by line. You have to go here inside the function body. You see, okay, there's a loop that is iterating over the products, and then for every product it is checking whether the rating is greater than 5 and the price is less than 100, and then it will push inside a new resulting array. And so this is a very much code, a style of code that we are used to writing as a series of steps, which means you have to read the whole thing as a story. If you look at this code written by you after a month or so, you won't have any idea what this whole function is doing. You'll have to read it as a whole story. So as a sequence of steps, right? And who is good at writing, understanding the code as a sequence of steps? It's the computers who are good at doing that. But as humans, we aren't very good at it. So what will be good for us is to write code in a more declarative manner so that we can understand what is going on. So this is the imperative part, and it's so even though you see this thing has a keyword function, you haven't been actually writing function. It's a procedure. So in procedural programming languages like I don't know, BASIC, you used to write number of steps. Okay, declare a variable, put this value into that variable, and flush it out, something like this. So in the similar manner, you're writing your code here as well. So this is actually a procedure and not a function. And so there are so we'll see how. So this is an impure function because it's causing a side effect by pushing the product that has been made into the best products array. And these are the few characteristics of the imperative code. So our purpose while we are trying to do functional programming is to reduce the imperative code as much as possible. So now this is imperative code. As opposed to this, there exists declarative code. So declarative code, the declarative version of this thing would look like this. So first of all, we broke our code into manageable piece of manageable chunks of code called as proper pure functions. So you see, we took out the functionality, took out the logic of deciding whether the product is a best product into a separate function. And the whole job of this function block is to, simply take a product and return a boolean based on some logic on that input. And then again, the get best products will just perform a filter check on the input array of products. So we divided our code into these tiny functions, and then our main function, which was best get best products. So we interweaved the functions together in order to get our output. So now if I read this line, const best products equals to get best products and products input. So I can read it as in the form of plain English, right? So get best products, and I'm giving it a input of products array. And inside here, if I read this line, products.filter, check if best product, and check if best product, I know by reading that it'll check whether the product, it'll perform some logic. So by reading it, this is what I mean by being a declarative code. So you won't even have to delve inside the function at all to check whether what it is doing. It might be doing some very complex logic here. So compared to the previous one, the imperative one, this is more manageable in terms of code reusability as well as code chunking. So that's about the declarative one. And there are key characteristics like each piece of functionality has been assigned a function which is supposed to do the job, which is limited to that responsibility. And these are based on pure functions, like it's not performing any side effects. We'll see what side effects are in a moment. And you can read the code in the form of plain English and deduce what could be the output without reading the whole program as a story. And of course, there are benefits of reusability and composability. We can consume this check if best product function somewhere else in our program without having to write the logic again. So these are some things we are getting out of the box by switching on to being a little declarative. Now let's talk about pure functions, because this is the very much fundamental aspect of functional programming. So pure functions are, if we go back to the mathematical definition, these are functions. These are functions which, when given a given value, returns the same output. So for example, we know that sine 30 is going to be 1 by 2. It'll never be the case. It's going to be anything but 1 by 2. And the second characteristics of the pure functions, it has no side effects. So we'll see what are those in a moment when we'll discuss about the impure functions. So this is one pure function, f of x, 2x to the raised to power x raised to the power of 2, x squared plus 3. So if I pass x as an input value to this function as 0, I'll get 3 as the output, 1, 5, and 2, and 11. So this can never be proven as false, right? Because this is based on the mathematical calculation. It will always give 3, 5, and 11 for the given 0, 1, and 2 outputs, and so on. So if you can imagine if we plot this up, if you can imagine, this is going to be an equation of a parabola like this. So if we translate this pure function into our computer science code, it will look like this. The function parabola, it takes x as an input and 2 and these calculations. So, and we'll write the tests like this: parabola 0 equals to 3. So these will always be true. It won't be the case they'll turn up false. So that's the benefit. What I'm trying to convey is the benefit of pure functions to have is they reduce the surface area of having errors in the first place. So you can be very confident about this piece of code. I mean, this can never be proven false because these are, mathematical calculations, and maths is, always true. So this is example of pure function. And let's discuss about some impure functions, which we might have been, used to using it a lot in our programs. So this is a count function, sorry, the count variable, and we have this function increase count by this amount. So here we are mutating a variable outside the function scope, which means, and it's returning that count. So which means if I call it for the first time, I'll get 1, and for the second time, I'll get 2. And if I change the count variable in between imperatively, I'll get a value of 3. So you can see the outputs at any given point of time, you can't guarantee what the output is going to be. So writing a test case also might fail in a given situation, right? It all depends on its surrounding environment. So this line right here, is causing a side effect, count plus equals to val, because this function is mutating something outside of its scope. So this is in essence a very much an impure function. And similarly, there are some inbuilt functions in JavaScript which could be impure. If you can you name any functions which could be impure? Is there a way to provide the input in the air meet? Anyone? Or you can write in the chat. Splice. Someone said splice. Yes, that's true. Yeah, because that mutates. Very nice. Any other functions? Push. Yes, that causes that mutates the input variable instead of returning the output. Shift. Array methods. Yeah. Any other? Most of these are array methods. Okay, I have a very prominent one example. It's called math.random, right? Or just the date. At any given point of time, you can't guarantee the output of math.random. It's always going to be random, right? And date also is an impure because it returns different output at given point of time. Cool. So that's about pure versus impure function. And for the characteristics of pure functions is that given a same output, it always returns the given the same input, it returns the same output. Now, there exists a term in functional programming world in other languages. So we need to understand that functional programming is not just related to JavaScript. It has been taken from, inspired from other languages like Haskell and Scala, which Haskell is a pure functional programming language. JavaScript is not a functional programming. It supports functional programming, but it's all upon us whether we want to use functional programming or not. So this is one of the terminology that has been taken from the functional programming world. It's called as referential transparency. So what this means is so wherever you find yourself in a situation where you have to deduce that whether a given function is pure or not, that can be reduced by the fact that if you can replace a function call with its resulting value without changing the meaning of the program. It means that consider we have this function add here, and there's a multiply function, and the result goes like this: add 2 to multiply 3 and 4. Now, if I can, so I know the result of 4 into 3 is 12. So if I can change this value, change this parameter here to the resulting value of this function without changing the meaning of the program, I can say that yes, mult is a pure function, so which is there in our case. So this whole thing is called as referential transparency. Then let's talk about how we can implement functional programming in our application. What are the steps of moving towards the functional programming world. So first and foremost, we'll have to make sure we are writing pure functions. It's not always going to be the case wherein you will be able to write 100% code in pure functions, because there are impure there's an impure in aspect of development as well in your application, because we are constantly making network requests where we can't guarantee that we'll get the same result at a given point of time. We are writing console log statements, which is also an IO operation, so that makes our code impure. And but our focus should be towards writing as many pure functions as possible and taking those pure functions out, so that they can be reused everywhere. And the next thing is to compose and interweave the functions together to build more functions. And those more functions are called as higher order functions. So if a function returns output of another function, which in turn might return an output of another function, so all these functions on top of the very inner function are called as higher order functions. And the magic that we'll get out of these writing these individual pure functions are code modularization and reusability. We'll see while how that works while just writing or chunking our code into these functions. And we have to make sure we reduce the impurity surface area. So we'll see in a moment about that. So let's discuss what a higher order function is. So you might have seen this thing in our 11th standard maths in the functions chapter, f of g of x, or it goes like this. The very common example or practical example I've seen for this function would be, so there's this toggle model function which takes a state value of the model as an input, just as a boolean, and it just using the use state in React, you can set it to be either open or true, open or not, and these are some wrapper around these functions for ease of usability. So open model will call this function, and closed model will call this function. So both these functions are high order functions because their output depends on, they are wrapping themselves around this inner function called as toggle model, right? So that's what I mean by high order function. A function that is wrapped around another function, just like we have high order components in React app, wherein a component encompasses other component inside it. Then let's talk about containing and reducing the impurity. So what this means is, as I mentioned earlier, so if you look at this code snippet, it says it's a function that says get user. So when you'll call this function, it'll make an API call, and then it'll parse that response into JSON and build a user out of that user's map, and then it'll console it out to the log. So as you can see, this is not a pure function. This is an impure function. Why? Because it's making an API call here, and it's not very much segregated also into individual functions assigned to do their individual jobs. So the pure version, or attempting to be as much pure as possible, version would look like this. So we have this toJSON function. So we have broken the the individual operations into their individual components, individual pure components. So by taking out the functionality of response.json into toJSON function, we are making this functionality as pure. So you see, if now any error occurs anywhere, so for example, the new user object wasn't getting the image, maybe because we are destructuring the wrong property. So you would know that okay, there's problem in the build user function, so you'll directly go there and change it rather than having to look at the whole code base right here and changing somewhere here. So by doing this, we are reducing the surface area of impure functions as much as possible by extracting them out into pure functions. And the other benefit of doing this is these are more testable now. So you can test this build user function in isolation and guarantee the outputs of this function based on the given inputs. So this function right now, get users, it is still impure. It can't be made pure because it has this network IO operation, which is needed for our project and for our code. And there's nothing wrong with having impure functions. It's just that our approach should be towards making our code as much pure as possible. In practical world, it would be like this: some impure code and and more of the pure code. An ideal case would be where everything is pure, but that won't happen in practical apps. Okay, let's talk about other things like composition and piping. So we meant in the higher order function slide, we saw how this thing is f of g of x, or it could be f of g of h of x, like that. It could be a chain of several functions together, performing bound together to have some output. So consider this function process number R1, R2, and R3. So these are three steps in which it's doing some mathematical operations. And we just pass it an input and it gives us number 36. So by seeing this function body, you can tell that it's happening as a series of three steps. So rather than writing it in the imperative manner, we can write it in the declarative manner, first of all, by segregating the responsibility, segregating the code into the individual functions like this, and then we can perform this composition pattern, which says square, double, and add one. So this thing will get performed first. Add 1 to 2, 3, and 3 to 2 would be 6, and 6 are 36. So that's how we'll get this output. So that's about function composition. And how composition works in functional programming. So what we do is we can create this compose utility function. So this is a higher order function which takes in functions as its argument, and it computes the output of each function at a given step from the right to left fashion, as we just saw in this example here. So this will be computed first, and the output of this thing will get fed to this double function as the argument, and the output of this whole thing will get fed to the square function in the very end, and then we'll get the result. So similarly, I can create a function called as process number by composing these functions together. And this compose is our very first function programming utility that either we can write ourselves like this. It's a very simple implementation. It's a reduce write, which takes in the function from the very right and feeds the output to the upcoming ones. Either we can use this, or we can rely on the libraries, the function programming libraries, like we have Ramda, which we'll discuss in the second part, and we have Lodash-FP also these days. So this is our very first example of introducing a function programming utility in order to build function or compose functions in an easier manner. So the benefit is that we didn't have to create a function with a function keyword and write this whole logic inside it. We just created our process number function by adding these, by supplying these functions to this compose utility. So this is the very much essence of functional programming, where you are not writing functions in an imperative fashion, rather you are composing functions out of the existing functions. So this is a very contrived example. In the second part, we'll actually work on a to-do list application when we'll see these patterns throughout composition piping throughout the code. And so yeah, we are writing code as an association of functions rather than a series of imperative steps. So this is very important when it comes to writing functional code. Great. Let's talk about piping. So similar to composition, we have this other pattern. It's called as piping. So if you learned Linux, if you perform Linux commands, it's very much inspired from that, the terminology, wherein the output of the previous step can be fed to the output of the next step. So this is a command which basically gets the word count in a given directory, word count of the files in a given directory, sort them by the ascending order, and take or slice out the first three results. So as you can see, the output is moving from left to right fashion as opposed to right to left fashion in the composition. So it's the same as compose utility, but it works in the opposite direction. So some people prefer this notation, piping over compose, because it feels like the natural order due to this thing we have already. So instead of having add in the last place, so we'll move in the left to right fashion. And instead of using reduce right, we use just reduce, right? So yeah, it'll give the same output, but it's just a matter of preference whether you want to use compose or pipe. Any one of those are fine. Cool. Now, before moving any forward, let's discuss about function shape. And if you probably belong to the Python background, you can relate to this more easily. So function shape represents how many arguments of that function are. So for example, a function with one input is called as unary, two input is called as binary, and with n inputs is called n-ary. So consider this example. We have this users array, and we have a little utility function wherein we want to combine the first and last name together with a space, and we just want to map them out. So the normal way we use is like users.map user and get display name user. Now this line right here, so as you can see, this is a argument which is again being fed to this function argument. So both of these functions, this particular one, this anonymous function right here, and this get user display name function right here, they both have the same shape, right? They both are unary function. They both accept one input and return something. So what we can do is instead of writing this inner function, we can directly pass get user display name function right here. And that pattern, which we already have been using a lot, is called as point-free programming. Now, this is again another jargon that has been taken from the functional programming world, and it's nothing fancy, rather something which we have been doing already throughout, and wherein we replace try to use the functions rather than writing rather than writing the anonymous functions, which just saves us a lot of keystrokes, not a lot of, but few keystrokes, due to the virtue of having the same shape. So this is a very prevalent pattern that you'll see throughout the functional programming patterns, functional programming coding. So this is called as point-free or tacit programming, and point here refers to the function argument, like the user in this case. And now consider this case wherein I have an add function, which is a binary function. It takes two inputs and return one output. Now I have this functionality wherein I take in an array of numbers and increment all those numbers by one. So I'll have to do something like this: add 1 and v. So now you can see, right? I can't use that point-free notation here just because this was a binary function. Had there been a way to make this function unary by applying 1 somehow partially to it and having it return some another function which will automatically add 1 when we'll pass the value to it, it would have been great. So in order to tackle that, we have something called as currying. So this is one of the very popular buzzwords of functional programming world. You might have heard about it mostly when we go for the interviews and people ask about it. And its name, it has nothing to do with the Indian curry that we eat every day. Rather, it has to do, with the name of the American mathematician called as Haskell Curry, and based on which there's a dedicated programming language as well called as Haskell. So, so currying is a concept wherein you can, so it's a higher order function utility. So curry is a higher order function utility which helps us achieve currying, the concept of currying, and so you can apply you can supply a function to it, and all it does is, so consider this multiply function. It accepts a and b as its parameter. Now there might be the case. So this is a binary function. So this is a way of breaking the input arguments of a given function into individual unary functions by returning inner functions from it. So we won't go over the inner implementation details of it, but all you need to know is that instead of supplying all the arguments at once to the multiply function by forming a curried version of multiply, you can perform the operation like this. Like either you can pass 2 and 3 at once, or you can pass 2 and 3 as their individual arguments. Now, let's see how this fits our previous example. So we have this add function. We created a curried version out of it by using this curry utility and passing it the add function as its argument, and we get another function out of it. Now this is a curried version, and what I can do is I can, you saw, so we can pass the function arguments one by one. So for example, when I did add 1, so it returned me another function, and only when I pass the second value, second argument to it, only then it will be resolved. So now that this function has been made unary, its shape is now equivalent to what's expected in the map callback right here, right? So now I can use the virtue of point-free style, the point-free programming, to simply place my function right here and expect the output to be, have the number added by 1, simply. So this is one of the benefits of currying, that it helps us achieve the function shape, the desired function shape that we want. Now let's see some practical example of it. So consider we have this Ajax function which accepts, whose job is to make a network call. It accepts 3 arguments: the URL, the category, and the callback function. So so for example, I want to make an endpoint that says fetch products, and it accepts two of these arguments, Ajax, and I'm applying the first argument and taking the other 2 arguments in the callback, and then again, so I'm kind of reducing the, so I'm kind of making abstractions. So for example, if fetch bathroom products or fetch kitchen products are the functions which are going to be used very widely throughout the app, so it will be wise to create, to partially apply these things to them, and just take the callback argument to run it anywhere. So this is how we'll generally abstract our code, right? So this can be done in a neat way by using currying. So I can pass this Ajax function into the curry utility and get a curried version, and now I can pass the arguments individually, one by one. So I have this fetch products, I pass in the first argument, and then again to this fetch products, if I'll pass the second argument, which is a category of kitchen, and in the third argument, if I'll pass the callback, then that's when the output of that thing will be computed. So the way this curry utility works is it takes in all these arguments, it sees, okay, the argument's length is 3, so only when the last argument is passed, only then it will compute the output. So this is one very nice example where currying can help us. It's called as partial application. And in fact, partial application is so common that we have another utility called as partial. And what partial does is, for example, I have this multiply function, a and b, and what I can do is I can partially apply the argument to it and have another function return, so that when I'll pass it, the final output, it gives me the same uh, output, basically the final output. And again, this kind of utility is available on all the functional programming libraries. It's called as, in Lambda, it's called as r.partial, and in Lodash also there exists something like this. So yeah, similarly, so the way this partial utility looks like is, so we can have partial and multiply as the first argument, which accepts, let's say, 3 or 4 arguments, and I can I can partially pass it any number of arguments I want. I can even pass it 3, but that would mean I have simply computed it by passing all the arguments at once. That's something we wouldn't want to do since we are partially applying. So I can partially apply 2 parameters and expect the third parameter to be passed when in the next step. So this is how the signature of this function looks like. So that finishes up, by the way, with our first part of this series. And before moving on to the second part, let's have a little breather, because I think it's a lot to sink in, and it's going to be more challenging in moving forward. So let's take a breather for like 2 minutes, and I can take up any questions also if you have at the moment.
Yeah, so Param, I think there are a lot of questions. If you go to the question tab, you can see all
Okay,
the questions.
yeah,
If you
let's
scroll down,
address them.
yeah,
So,
sorry,
Tanmay,
sorry. So,
mhm.
yeah, so this is a chat section. So if you see on your right corner, there is a question tab also.
Question
Yeah,
tab. Yeah.
yeah,
Okay.
yeah.
So what is the cost of passing huge arrays and returning again, or is it a trade-off between maintainability and performance? So functional programming, these principles like map and reduce are the essence of things like big data, and there are solutions to that. There are some nice solutions called as transduction, wherein you can parallelize these operations. And in normal programming, it's not very much of an overhead. But yes, in huge when it comes to performance optimization, there are solutions for that. There are very high and sophisticated utilities called as transduce, which are there to help these kind of things. Can network requests which give consistent response be considered pure functions? No, it can't be, because network request, you can't guarantee an output from a network request, right? So, I mean, anything could go wrong. Your internet could shut down, right? So, anything that comes outside that depends on the browser APIs, right, can't be considered as a pure function. So even your set timeout, it can't be guaranteed because it depends on the um, existing resources of your browser. So the answer is no for that. What is the difference between time complexity between the two implementations? Okay, I kind of missed that. But I believe we are talking about the map and reduce product filters. So yeah, it's just O of n, I guess. Yeah, there's no a multiple or nested sort of thing, because we are anyway um, calling those things in individual steps. And isn't composition the same as function currying? No, they are very different things. Composition is a pattern wherein we pass the output of a given step to the next step, and currying is a way of decomposing, mutating, or changing the function arguments, and having it allow taking individual arguments at a given point of time. Okay, then there is what's the difference between function composition and function curry, or are they both same? Okay, we'll see how what currying is in our coming thing, so it'll become more clear with a practical example. What is reduced right? Is inbuilt API? Yes, it is. It is an array prototype function. So, it's just the way a normal reduce prototype function works on arrays. It's just that it starts from the end rather than the beginning. So yeah, it is a proper inbuilt JS API. Any disadvantage of functional programming? Yes, there are a couple of disadvantages of using functional programming, and we have that covered right in the very end of our session. So, cool. I think we have a lot to discuss. So I'll jump on to the next part, or else we'll run out of time. Any other questions, guys? Or are we good to go?
Yeah, are we good
We'll,
to
we'll,
go? Do you guys
mhm,
feel we need a break?
mhm.
I think
Variable
we're good.
length arguments, how to tackle. Yeah, through currying, we can handle that. We'll see in the second session, it'll become more clear. So let's talk about how you can use. It's very much impractical to have all these utilities created by yourself. Just like we saw compose, we saw curry, we saw partial, we saw pipe as these utilities. You don't have to write these utilities. There are existing libraries which have been there for a long time, and they have implemented it with a very largely backed community support, and one of them is Ramda.js. And to give a little insight about Ramda, it came into existence in 2013, and as you can see right now, even right now, it's still well maintained. I can find the TypeScript support for Ramda.js as well, and it became really popular over this period. And I remember, one of my colleague telling me, "Oh, Param, there's this library called as Ramda.js. It uses functional programming and everything," and I couldn't understand it at that moment, but now that I do, I see what benefit it holds. And we'll be using this library. The purpose of this next minutes would be to redo or implement a to-do application, a practical to-do application in React.js using Ramda as a supporting library for endorsing the functional programming principles and patterns. Okay, so this is how the app looks like. It's a very small, tiny app, a to-do application which takes in, okay, ABC. It adds whatever you type in here to the given array of to-dos right here, and you can check any of the to-dos, and it'll cross it and adds it to the state of completed to-dos. So this to-do can be either in the complete state or in the pending
Hey,
active state. Yeah.
sorry to interrupt. Would you possible to increase the font of that? I mean,
Oh, okay. Sure. Thanks for notifying. Yeah. So I was saying, yeah, so these are individual to-do arrays right here, which, as you can tell, are wrapped around the map function. And just like we do normal, the map operation inside the JSX, that's what it is. And that's it. On pressing enter right here, I'm having this functionality of adding the to-do to the given array, right? Okay, and if I add the same to-do, if I hit enter again, it won't get added to it. So we have to accomplish all these things into our code. So it's available. So by the way, all the links and everything are there inside this slide. So I'll share all the links, in the very end, so you don't have to worry about that. Cool. So let's see how the installation of Ramda looks like in any project of your choice. You can add Ramda like this, npm install Ramda, and if you're using TypeScript, you can add types/Ramda, and using yarn, it will look like this. And as I said, this library has been there for very long, before even npm existed. Maybe you can add it just like you used to add jQuery from unpackaged or Cloudflare CDNs like that as well into a browser. Okay. And the usage looks like this. In our modern day world, we can import it as import star sr, or you can destructure the individual utilities from it, individual functions from it, like this. Or if you're using, any environment, even Node.js, you can use this common JS syntax right there. I prefer to use the first one because you won't, so that you won't have to, destructure every utility every time you use it in the project, in your code, anywhere. So you don't have to go up and write it or depend on your VS Code IntelliSense to do that. So I prefer this kind of syntax a lot, but that's just a preferential sort of thing. Cool. Next is about what's wrong with this. Order partial. I'm sorry about this. Okay. Um, okay, I can show what this is. So by the way, the application looks like this. In the app.tsx, I'm calling this. Okay, let me increase the font size. In the app.tsx, I have this to-dos, and this to-dos is present inside the referring to the index.tsx in the to-dos directory. And here I have this input search box, which represents this thing right here. And in the bottom, I have this to-dos.map make to-do item right here. So this make to-do item is creating this to-do item component, which is present inside this file. And we are focusing on this piece of code right now. So we have a make to do function, which takes in the status, and the status could be, it's an enum, which could be completed or active, and it takes a string of the to do. So by default, when you create a new to do, it will be active in an active state, and only when you check it, it will be in the completed state. So that's what this image should be about. And so what we want to do is we want to basically, so we have this function make to do. It'll be better if we could create another function called as make active to do and make completed to do. Now it looks like a partial application pattern to me, wherein I want to supply one of the arguments, and it should return me another function to which, if I supply the text, it'll perform this thing for me, whatever is there inside this function body. So r.partial looks like a perfect candidate to me here. So that I can simply execute the function. I make active to do when I first create a to do when I hit enter in this thing, right? So this is creating an active to do. So by applying r.partial, I'm able to you know uh, partially apply the argument and create a new function. And similarly, I can create make completed to do as well. Cool. So that was one usage of, so by the way, Ramda has like 257 of these functions, and it's impractical for us to discuss all of those, but I have jotted down here, tried to demonstrate the most important ones, and let's see, we'll cover most of the important ones that seem to have been used, for this whole, for making this whole application. And next one is r.curry, which again is, as we discussed, is a curry utility. And for example, we have this change to do status function to which I can apply two variables, two inputs, status and to do. And again, I can pass make to do and to do.text. Now this is the variation I had to make. Otherwise, I could have passed the whole thing right here. So if you do this r.curry, you can now apply the individual functions to it. So the usage of this thing we'll see in the when we'll reach towards the very end of this deck. But yeah, this is another utility, simple utility, so that you don't have to implement your own curry function by yourself. Now let's talk about the statements. So you have a checkbox which takes, so this is an ant design checkbox, and which takes a boolean to see whether the checkbox should be checked or not. So you have to do that by checking the status of your to do. If the status of the to do is to do not completed, then return true or false. Simple. Now, if you were to write this thing into a function programming thing, it would look like this. So we'll extract this functionality out into its individual responsibility function, which looks like this. And I can then, call this function with a given status and store it in a variable and use it here. So you can, again, right now we haven't used any utility library, utility function from Lambda, but still we have made our code functional, right? So that's what I mean by when I say you don't have to use a third-party library in order to make your code functional. But yes, using these libraries will make your code more less verbose and provide you with some very handy functions. So similar to this, so if we were to implement this thing, there exists a utility just for this triple equality, by the way, which seems a little overkill, but you'll see the benefit of these things when you'll see the again, this thing is not working, but I'll just show you. R dot equals something like this. Get checkbooks, yeah, something like this. So I just replace that this function. Okay, it's right here. So this line 32 is equivalent to this 34 line function. So it says I'm creating a function by using this function utility which says r dot equals, and we are telling what we want to equate to on the right hand side of the expression, and this function will then take an input and it will try to equate it and return its output as a boolean. So this is one utility for writing the statements in Lambda in simple terms. So this is the very much, essence. This is the kind of pattern that you want to see when you're implementing functional programming, that you are composing functions by not writing them, rather using the existing functions that are there. Next, again, is if else, which again seems very overkill. Like, why can't you use a simple ternary operator? That's the very first perception when people see this. And so it goes like this. At the first argument, it takes a predicate function. So the use case here is we want to strike through, have a line through style for the completed to-dos. So in order to do that, I have this text decoration get line decoration, and is checked get checked value from to-do state. So we are reusing this function, in order to use this text decoration style. So that's the benefit of having the functions chunked out in the first place. And this get line decoration is a ternary operation, which is like an if else. So the first argument is, so it will check if is checked is equals to true. And in the second and third argument, it accepts those truthy and falsy values. So all of these are functions, right? At every step, they are functions. So r dot always is a utility which is like a identity function, you can say, which when called always will give line through, and none will always give none. So everything you see has been converted to functions, pure functions. So this is the kind of pattern you'll see a lot, and this will become very much apparent when you use the composition and piping. We'll see in a moment as well. Then there is r.path. If you are very used to using lodash.get, it's similar to that. You just path. So path is a function which accepts the array of properties that you want to traverse inside a given object. So it could be a deep nested object, and you want to get the nested property at the fourth level. So you can traverse like the path, specify the path of that in an array as a first argument, and in the second argument you can pass the object itself. And by the way, all functions in Lambda and other FP libraries are curried by default, which means I can either pass both the two arguments right here. I can either pass the event right here by putting a comma event, or I can pass pass them one by one. So both of them are allowed. So it's called as variadic currying, which means you can use the both kind of syntax. So there's no limitation that you have to pass them one by one. You can pass them all at once, just like you do the normal functions. But our purpose is to make this thing unary so that we can use it in the composition pattern. So by the way, this is another use case wherein we have a handle change event, which gets triggered when you click this checkbox. So when you click this checkbox and design a component, gives you with this event, which is the normal checkbox event. And in order to check whether the value was checked or not, you have to extract event.target.check. So we can take this functionality out into check function and pass it in the event, and it'll give us the final result of it. So that was about path, and let's talk about composition and piping now. So we want to create our onChange handler, which gets triggered once we right here. So once we change our checkbox, once we either check it or uncheck it, we want this handle change to handle it. And what we want is we want to update the status of this particular to-do to be from being active to be completed. So if we were to write it in the normal fashion, in the imperative fashion, it would have looked like this. On change, if event.target.checked is true, then set the status to completed, or set the to-do active, set the status to active. So by the way, this on change is another prop of this function because this is a to-do item component. It's a presentational component which whose output goes back to the parent component, which then handles adding the to-do or updating it in the array. But right now our purpose is to make this more functional. So we don't want to create this function by writing these curly braces and having these brackets and writing this body by ourselves. Rather, our purpose, remember, is to create functions from the existing functions. So we can use our path function that we created earlier, and we can, let's see how it will look like as a composition pattern. So I can see this handle change function as a series of steps, right? So first of all, the very first thing to do is chunk these functionalities out to their individual responsibility functions. So I've taken this functionality of whether deciding what would be the status if whether it was checked or not into this check if checked, the path function that we found earlier, and call on change. I'll come to this. And then this is our handle change function, which I created by weaving the output of all the functions that I have with me. So as you can recall, the compose pattern works from right to left, which means this check if checked will get executed first when we'll pass it the argument, and this argument would be event when the on change event will happen, and whatever the output of that is would be passed to the boolean, and then next, right? So let's understand it. So at the very first, it'll perform this function, and it'll return I guess an enum or a string, you can say, and it'll convert that output to a boolean. So this is like the JavaScript boolean version. Similarly, to use the double bang, double exclamation notation, it's similar to that. And here we can use the benefit of having that capital B boolean right here because that's a functional notation. So that's a very nice use case here. And once we get true or false, we want to we want to get the status. Oh, I think I messed up. The first one is to get the value from target.check and then convert it to boolean, and then from that boolean value we'll find the status of that to do, and then at the very last we can do this call on change. So this is a way of calling a function in a series of compose or pipe kind of steps. Now this thing right here, if you are able to achieve this, you'll happily get certified that you are using functional programming. So right here, it is difficult to achieve in certain cases because of the impurity. It becomes hard. If you try to do right now, you go to your project and try to do this, you'll come under, you'll face a lot of challenges. How do I do this? How is this even possible? Is there a utility for that? Is there a utility for this thing or not? So, but that's what all about. With more practice and seeing these things as these patterns in your mind, you can form this. So with a little practice of, let's say, months, you'll be able to achieve this. And if this is the whole essence, what I'm saying is of writing functional programming, that you can create functions out of existing functions. So now if I were to create another function by reusing any of these individual functions, I could create them, rather than having to write more imperative functions, which could, duplicate the code as well. So that's the whole benefit and point of using functional programming in the first place. And again, similar to this, we have r.pipe. If you don't want to, because many people find it confusing to having to move from right to left fashion or bottom to up, we can write it in the natural order by using pipe, which is left to right, check if check, 1, 2, 3, 4, like this. So some people prefer this, and some people prefer compose, but most of the time people prefer pipe a lot, even myself, including myself. Okay. Now I was saying, if you are using TypeScript in your project, now I'm being honest here, it might look a little verbose, as you can see. I've added comments, so it's looking more verbose here. But just for the sake of understanding, you'll have to pass it a generic, otherwise it will be any. So it won't give you any benefit. So you have to pass in the input argument as the first type, and in the second argument you'll pass the output of checkif check, which could be either boolean or undefined, because we are checking the target dot checked, and that could be undefined as well. And here we are coursing it to boolean, so the output of that will be boolean, and then to do status, and then void, like this. So if you're using TypeScript, you'll have to do that. And let's talk about lengths. We are approaching the end of our session, so please bear with me. This is a very interesting thing, by the way, lengths. So consider we have an array of to-dos, like 5 to-dos, and I just want to focus on the third to-do. It could be a very nice example that I clicked on the third to-do. I checked this item, and I want to change that particular to do, and I don't want to touch any other to do, of course. So it's a way, so there exists various length properties, length functions like length path, length index, length prop as well. So since we are talking about the arrays, we'll use the length index property. So what this does is, it kind of creates a focus on a given thing, so the analogy is coming from a camera lens. So like a camera lens is used to focus on a given thing. Similarly, using r.lens utilities, you can focus on a given point or a given space in your data structure. It could be an array index, it could be a deep nested object property, it could be a normal object property, or anything. So I created this lens, but how do I use it? So there are 3 utilities: r.view, r.set, and r.over. We'll see how that works. Now, I created this lens, and if I want to view what's being focused in that lens, so I can use this r.view utility, and I pass in the lens as the first argument, and in the second argument, I can pass in the array of to-dos whose index I want to focus, and it'll give me the reference of that to-do that I'm looking at. So this is our first utility. And again, as I mentioned, all the functions in Lambda are curried by default. So either you can pass it using this notation, or you can pass using this notation by passing them individually. The second one is r.set. So again, you create the lens, and using r.set, you can actually change the given space in your data structure by passing it an individual argument of like the second argument right here. So it's change to do lens, and then you create a new to do, whatever you want to add there. And the third argument would be your actual the data structure to work on, and it'll give you, and remember this thing, all functions are pure. They won't in any way mutate your data structure, just like push does, or someone mentioned splice does. It won't ever do that. It will return you an entirely new set of new to-dos, right? Just like map or filter functions work. So map and filter are actually the very nice candidates of functional programmingness and built into JavaScript itself. So yeah, that's about r.set. And then r.over. Now there could be a case wherein you might want to perform some functional logic by checking the value of the existing thing at that given space in your data structure and making something out of it. So for example, we have this make to do thing. So if the person checks this particular checkbox, I want to grab that reference of the to do and change its status to completed, and but keep the text same. So I have the status, the new status right here, and the text is being copied from the to do that's being watched out. So it can be used by doing this r dot over the to do lens as a first argument, and the second argument, instead of taking the value directly, it'll take this function right here, which will perform some logic. And in the third argument, either you can pass here, or in the next step, you can pass to do's. Now, moving on to curry. So how we can implement curry? So we can't use this make to do function right here. Why? Because this is a binary function, right? And since the shape of this function versus this anonymous function that's present here is not fitting, right? So what do we do in that case? We have to make sure that those shapes are equivalent so that we can, bind them together, just like a jigsaw puzzle. So you can't, so the shapes of the two pieces have to match, right? And that can be achievable. That can be achieved by using curry. So instead of using this function, I'll curry this function, like, and thereby I can pass the status like this, and it will return another function which will take the to do, and that's all we want right here. So I hope that's clear. It's not that confusing. It might look a little odd in the first glance, but once you get used to it, you'll see these patterns throughout, this point-free style notation, making the shapes similar, converting functions into unary functions, binding them together. All these patterns are very much, a part of will be a part of your day-to-day life if you, start writing your code into function programming, using function programming paradigms. So that was, yeah,
Yeah, so there are a lot of questions coming up.
sure, we'll address that.
Yeah.
Okay. I hope I don't miss anyone out. Which one? This is out of topic. I want to discuss the object proxy and decorator. So these are the ES6 APIs, but which is out of the scope of this discussion. But yeah, I believe ES proxy API. It might have functionalness to it, but I'm not sure on that. It's an ES6 API. It's not, so functional programming doesn't have to do anything with ES6 or React or the current day things. It's more like a design pattern which can be used anywhere with any version of JavaScript. Is there a way to add partial application functionality for single argument function with an object as its only argument? So if there's a unary function, there's no point in having a partial application applied to it, because that's a unary function, right? You'll just pass it one argument and it'll complete its execution right there. Consider we are saving a huge amount of nested data using clone deep to make a loose reference. Is there a JavaScript built-in way to deep copy an array of objects and alternate kind of? I'm having a Okay, this is again a very JavaScript-y kind of question. We'll move to the next. I've implemented undo and redo functionality in my study work. Currently, it shows slows currently features that are clone deep. Okay, this is again about a clone deep. We'll move out of time. We can take it offline, by the way. Then there's what's a major difference between popular use case and functional style between Lambda and Lodash-FP. I have used Lodash-FP, and both of these libraries have similar, they are functional programming libraries. So there isn't much difference between both of these, but what I found is Lodash-FP doesn't have some of the functions which are there in Lambda, because Lambda is a very mature library. It's been there for quite long. So my preference would be to use Lambda over there. Main difference between pure function and impure function, we have covered that in the first part. Can you please tell how if-else works? Well, it's just an implementation of ternary operator. Just the difference is that it returns a function in the end rather than the value itself. Can we pass r.path take a string like get? Very nice question. You can't. That's something I have been looking for as well. Yeah, I believe. But definitely there would be some npm package for that. But Ramda doesn't sadly allow this. I understand what you're saying, like a string with dot notations into it. But it can be implemented very easily. Maybe you can use the Ramda utilities itself to create a new Ramda function and publish to npm as well. Okay, I didn't get the last one regarding r.over with curry. Okay, we'll touch upon that. I believe, yeah, it could be a little confusing. So the lens part is clear, I guess. We are focusing on one particular place in our array or thing we have, and then in the second argument, we can use this function. So the make to do. So our purpose was to use the make to do function right away, but we can't use it. I mean, we can't simply write make to do because it's a binary function. And this second argument, second argument takes a function which should be a unary function, right? We have to do as a first parameter. So we can't do that unless we change this, unless we create a new function that partially applies status to it and accepts another, returns another function which is a unary function which one takes the text, returns a new to do. So that's what we try to do here. So this, we created this new function, status, which takes two arguments, status and to do, and we curried it so that we can pass the arguments one by one. And once we pass the status like this, it means that this function is now returning another function because it's a curried version right here. It returns another function which takes into do as the argument so that we can use right here. Cool.
Yeah, so
Uh-huh.
I'm just seeing one more interesting question. So how much composition or functional is too much? I saw so it's
Uh-huh.
chat.
How much function composition is too much? Honestly, if you'll, there's nothing like too much here. If you use these things, you'll see emerging patterns out of your code. When I was trying to redo this to do application, I found how those functions that I created, chunk them out, they are being used across the whole application. So for example, even as simple as taking the r.path thing, it was used in other places as well. So there's nothing wrong in going all functional. It's just that you have to reduce the impurity surface area, as we mentioned earlier, as much as possible, and try to bring in more purity as you can. So it will be very much possible. We'll see some of the pros and cons in the very end as we are approaching near. So let's talk about Patro. How much time do we have? So that
Yeah, I'm sorry to say that we don't have much
Mhm.
time left, so I think
Okay.
plan for
So
future.
I'll quickly close then. So this is r.when. It's a conditional wherein it takes the first argument as its predicate function and execute the second one only when it fulfills the first argument predicate. And we have r.unless. So I have these code snippets, the code sandbox. It has all these things into it. Now r.x, it could be, there are plenty of functions. If you go to the Ramda documentation right here, you can see there are a lot of functions, right? And you can filter them out. And in total, there are 257 functions. So for all your needs, but these are the major ones that you might end up using in your application. And so you can see, right, just like Lodash and underscore JS, it has plenty of functions. And you might not even have to use Lodash if you are, importing Ramda in your project in the first place. So if you want to learn Ramda, and I can understand it can be very intimidating to see the documentation like this, it's very contrived documentation, and to see actual patterns. So there's this very nice, which deserves a special mention, I would say. It's an interactive Ramda tutorial that helped me a lot and that can help you as well. So you can say, okay, I have this kind of data structure, I have an array and I want to pull the property at a given index, pull the property of a given object at this given index. So you can specify your use case and it'll give you examples very easily. So this is a very nice tutorial I would recommend. And quickly, yeah, we are almost in the end. Let's discuss about the most sought after question. What are the pros and cons of FP? So let's discuss about the pros. The pros are it allows you to an immense amount of abstraction, you know, which you normally wouldn't be able to do with the normal things. Everything has been, abstracted into reusable, components, reusable functions, and we can compose new functions out of it. And since it's based on the truthfulness principles of mathematics, it leads to more deterministic codes, which means you can guarantee, you can have confidence on your code that it'll never gonna produce, the wrong results if you write the test cases and expect them to behave in a certain manner. And they are excellent for testing. Pure functions are excellent for testing. They can be tested in isolation and very easy for debugging, as we saw in one of the examples. So we know that at what step, what step things went wrong. So you reduce the surface area of impurity, and you can directly go to that function which was causing problem and change it. And in big data world, FP is, by default there. It helps in the parallelism, so you can distribute the map and reduce operations onto separate threads for performance optimization. And there exists some utilities called as transduction as well in Lambda that can help you achieve those performance optimizations. Now the cons are not everything can be made pure like IO operations. So in practical world, we have these applications which rely on network requests, AJAX requests. So we that area of impurity would be theirs, and you can't, you shouldn't be making that pure because that doesn't make sense. You'll have, console log operations, you'll have these network operations, so that is fine. And under the hood, if you see the computer, the system, the machines, they understand imperative stateful operations, right? In the form of series of steps. If you learn that machine coding in your microprocessors subject in computer science, you would be able to relate that. But as I said, FP doesn't have to do with what computer understands. Rather, it has to do with what humans understand. So you can read the program as a plain English language and understand what's going on. Learning curve is high. Yes, I agree. There's no doubt in that. But with practice, it gives you really nice benefit. And this is my personal thing. I find it a little verbose while using with TypeScript. But if you're comfortable with TypeScript, it shouldn't bother you that much. And the last one is, yes, this have been, talked about on the PRs. I've seen in my last company that, okay, why are we using Ramda for if else for a ternary operation? Why are we using this equals when we can simply use a triple equals? So all those sort of things. But the point is, if you are just using these things without other patterns, without composition and piping, it doesn't make sense. But only if you're using FP principles to the fullest, you're using it in entirety and not like particular few functions and change your code, change your 100 lines of code out of them, just change like 5 lines of code. It won't give you any benefit. So that's where it shouldn't be used. If you want to use it in entirety by making your code as much pure as possible and reduce the impurity as much. That's when you'll start seeing the main benefits of it. And these are some references. All of these things are covered in the functional programming part 1 and part 2 of my Medium series, Medium articles right here, and you can refer to that as well. And yeah, in closing, all I would say is it might be please don't give up on this. It is very that kind of thing wherein either people go towards it very religiously or they go very much against it, and that happens only because people give up at the initial phase because it is intimidating and it is difficult. I don't want to understate it that it's easy. It is difficult, and you'll find yourself stuck in situations where you'll find, oh, this is not even possible. Oh, how will I do this? How can I make this function fully composable without having this aspect of impurity in it? So that's when you'll start realizing the patterns, and you'll start researching and uh, start building it. And once you get more comfortable, it'll take like a few months to get, and for some people it takes like years of practice to master it. And even with years of practice, they can't say they have fully understood functional programming. So that's all I would say. Yeah, and I can take up the questions if you have time right now.
So, guys,
Okay.
just devote another maybe couple of minutes for if any questions. So you can raise your hand or you can type in your questions. I saw there are a lot. So
I
if
can quickly address these. Yeah, there are many.
Param,
Uh,
can you take
yeah,
some offline also, like on while our
sure,
session is going
sure,
on?
sure,
You can
sure.
take some offline also. So maybe
Yeah.
a lot of questions on the resources. So if you can post those in our chat, uh,
Oh, okay.
that also helpful. But I posted the blog also, which Param has written, which is on Medium. So yeah, so
Yeah.
you go
So
through.
this slide has all the code sandbox and all these things I posted over there. So we
Yeah,
can take all the questions offline. Yeah. I'll give it to Abbas now because he also, yeah. Mhm.
yeah, sure. So guys, thank you. I think Param, this was pretty and wonderful sessions. I think on the functional programming. Functional
Thank
programming,
you.
it's always a hot topic.
Yeah,
All developer want to use it, but I have seen in my development career also sometimes it's difficult to use, right? So
it
because
is. Yeah,
code is working and why go and change it now?
exactly.
Yeah, but I have seen the benefit of functional programming in its own right. So
Yeah,
it was a wonderful session, and I've seen your blog also. It's pretty descriptive what I found. So I'll encourage
yeah,
people also to go through this, so that if you have any questions, you can I think directly connect with Param on Medium itself for any of those questions, right, on functional programming.
yeah, yeah,
Okay, so stay tuned, guys. So our second session will be starting, which will be taken by Abhas. So we'll be resuming that session in couple of minutes. So stay tuned. So in the meantime, uh, you can go to the launch. You can socialize with other developers. So meantime, we'll be starting in another 5 minutes. We'll be starting our second session. Stay tuned. Saying connecting. Good go. Okay. I hope you guys are able to hear me. Some thumbs up, please. Awesome. Okay, so welcome back. So this is our talk two of our JavaScript Meetup 52, and this is again a very interesting topic because everyone must have faced a day where they say, "Hey, debugging JavaScript is really challenging." And for the folks who has really come from non-JavaScript background to JavaScript, right? They I have seen often complain, say, debugging JavaScript is really challenging. So this session is all about that. So Avash will talk about how we can debug our JavaScript with Engine 262. So over to you, Avash. It's all your stage now.
Yeah. Hey, hi everyone. So, I am Avash, and I mostly read stuff from the JavaScript specification and try to explain that by posting sometimes on LinkedIn or making some videos on YouTube. So I'll just share my screen. Yeah. So this this talk is also going to be about the same topic. It's about let's say you face something, you see some JavaScript question in the wild, right? Some kind of JavaScript quiz, and you want to understand how it exactly works internally, right? So let's go through some example. Uh, so let's say you just search on Twitter, and let's say there is a question like this, right? Where someone asks that you have some variables A and B, and what happens if you do incremented using plus plus, like in the prefix or in the postfix, right? How does it work, or what will this print, right? So oftentimes, this can often into even get into even more detailed sort of explanations, right? So some of these things might be easy to debug, some of these things might be hard to debug because you can't really see inside the JavaScript engine, right? You can't really see exactly what plus plus a is doing, right? You kind of, you might have read it from MDN, or you have some idea of how it's working, what is happening to a, what is this thing going to return. But sometimes, right, it is much more useful if you can go and put debug points within a JavaScript engine and see how it is working, right? So that's what we'll try to do today, right? And like I said, we can go into a JavaScript engine and debug it. right? So the question is like, which engine are you going to use? Now, most popular one will be like V8 or SpiderMonkey, which like Chrome and Firefox uses. But those are like, I guess, a little bit more hard to set up, or you have to read through like C or some other language, right? So it's a little bit hard to understand, right? So that's why there is another option. There is another, sort of, you could say like a simpler JavaScript engine, which is called Engine 262. Okay, so this is like a GitHub project, and I think the person who maintains it mostly, like Dave Snake. He is also like a TC39 delegate. So TC39 is like that group of people who, like improve JavaScript or like build the JavaScript specification, right? So he basically made this thing called Engine 262, right? It's basically implementation of the ECMAScript specification, like the JavaScript specification that is itself implemented in JavaScript here. So what you're going to basically do, right, like in this 30 minutes or so, is you're going to set up this JavaScript project, put debug points there, and see what happens when you do something like, A++, right? That's all we're going to do. Now, before we go in there, right? So why, another point about like, why is this useful? Why can't I just read the specification? Now, like, I'm skipping a little bit ahead here. Like, I'm not talking about what the specification is, right? Because a lot of you might have some idea about it. Like, let's say we use some JavaScript engine, right? Again, Chrome or Firefox or Node.js, right? Those are implementations of the JavaScript. But there has to be like one text, right? One, big piece of text which talks about how JavaScript should behave. So that is, this thing called ECMAScript specification. So it's basically just a huge HTML page. You can like go to this URL, tc39.es/ecma262, and it's a big HTML page which talks about like how everything in JavaScript should behave, right? But at the end of the day, this is just a huge piece of text, right? So let's say I want to read about what happens when you do A++, right? So let's say I somehow find the section where it's defined. So maybe it's called like postfix increment operator, right? And I go in here, and this is a piece of text which tries to describe like what should happen when I do this, right? But you can't exactly run it. Like, you can try to read. So, if you have A++, they're defining it as left hand side expression and then plus plus, right? And then talk about what happens to the left hand side expression. So it's saying that, okay, evaluate the left hand side expression. So if you have A++, you, or technically you could even have an expression, like, something in the bracket and like more stuff within it. But yeah, in general, evaluating the left hand side expression will give you like a variable name, right? You have A. From there, you can try to get the value of A and convert it to a number. So if I do, if I have like A equal to 3, and if I do A++, so first it will do is it will try to get the value of A currently. So current value is 3. So it will store that in old value. Then the second thing it will try to do is something like, it will try to add some kind of a unit to that number, right? But this is where things start to get more complicated, because it gets very hard to debug what is happening here, right? You can't exactly run it, and you can't say that, okay, I don't want to go into these details. Just for my piece of code, show me what is the value of new value, right? So we intuitively know that 3 kind of becomes 4 because it's going to add +1 if you do plus plus, right? And then it does something like put value and then returns the old value. But what I'm trying to say is that, this can sometimes become very hard to understand, because you can't skip part of it. You have to sort of mentally go through all of this, right? And even after that,